allows us to determine the nucleotide sequence of DNA. And in particular, I'd like to introduce some of the revolutions that are occurring in DNA sequencing that are now starting to make personal genomics a reality. In 1944, Oswald Avery and colleagues did an experiment that arguably has formed the foundation of modern molecular biology. What Avery and his colleagues showed was that DNA was responsible for the transmission of heritable traits. Or put more succinctly, that DNA was acting as the blueprint of life. 9 years later, Watson and Crick solved the structure of the DNA double helix, and in doing so, provided a mechanism by which this DNA blueprint could be replicated every generation. And then, about 10 years later, Marshall Nirenberg and Khorana and colleagues solved the genetic code. And what this allowed us to do was to take the sequence of this simple polymer of DNA, A, C, G, and T, and read out the proteins that it's encoding. And these three sets of experiments together really provided the motivation for efforts to determine the sequence of DNA, to do DNA sequencing. And the major technology for about 30 years, from the mid-70s to the mid-2000s, for sequencing it was based on an approach developed by Fred Sanger using something called Guy-De-Oxy terminators. So what is a Guy-De-Oxy terminator? How does it let us sequence DNA? As you know, normal nucleotides have a 5' end and a 3' hydroxyl. And this allows it to polymerize indefinitely into a long chain of DNA. A Guy-De-Oxy terminator has a proper 5' end, allowing the base to enter to be incorporated into the going chain. But because the Guy-De-Oxy nature of it is making a 3' hydroxyl, that effectively terminates the chain, preventing further polymerization. Sanger then used this trick of having Guy-De-Oxy terminators as an approach for sequencing DNA. And in outline form, the strategy would be you start with a template DNA whose sequence you wanted to determine, and then apply one of the nucleotides, in addition to its normal deoxy form, would have a small amount of this Guy-De-Oxy terminator. So, for example, if you put in a Guy-De-Oxy G at low levels, this polymerization would occur normally, except every time there was a C that was being read out or a G that was being incorporated, there was a finite chance that the Guy-De-Oxy species would be incorporated, terminating the elongation. So the net reaction is, for the G polymerization, you'd have different length polymers of DNA terminating at wherever there was a C in the template. This could then be repeated with the three other nucleotides, giving you different templates of different lengths that indicated what the nucleotide sequence was at that position. This is then paired with a method for reading out and for separating the pieces of DNA based on size and reading this out.